So hi everyone. The last topic in your Unit 2, properties of line codes and power spectral density of unipolar, bipolar NRZ Manchester coding line codes. Okay. What are the properties of line codes? It should be line codes, which means the continuous stream of zeros and ones are available in the transmitted signals. So we should understand what it is the continuous 0 and 1. Okay, for that we are making some basic codes. Okay, in DC component or line have a certain properties for that line codes. First one is a DC component. So that DC component is used for self synchronization and error detection. And another property, bandwidth compression and spectral compatibility with channels. Okay, we are using for bandwidth compression different differential encoding methods we are using, and we have a nice immunity also. Okay, and these are all the three properties of line codes. You have a DC component and bandwidth compression and spectral compatibility with channel. What is power spectral density of unipolar NR is a non-return to zero line code. So first of all, what is line code? Process of representing the bit streams, as I told you earlier, a sequence of 1 and 0 to represent that bit stream in the form of voltage and current variations. Okay, the first for that we are using line coding. We have common types of line coding are there. They are all unipolar, polar, bipolar, Manchester. So like many line codes are there. So in this we are going to see about unipolar NRZ and RZ. Unipolar coding uses a positive rectangular pulse, okay, to represent the 0 or 1. It's a high value of rectangular pulse is called 1, and low value of rectangular pulse represents 0. Okay, that is what represented here. Non-return to 0 rectangular pulse, what did it show? For it for logic 1 bit, a full logic value, full duration which is available, that is NRZ. So that is unipolar NRZ and unipolar RZ code is that the rectangular pulse in NRZ stays at a positive value, non-return to 0. It won't come to the 0 until end of the logic 1. Okay, when it comes to the 0 at logic 0, whereas in RZ return to 0 value, okay, it comes at the middle of the logic 1 value. Okay, so that is the difference between RZ and NRZ. The drawback of unipolar is that its average value is not 0. Okay, so which means it creates the significant DC component at the receiver. So we must suppress the DC component, but in this case it will present at the receiver. So polar NRZ code, if it is one data, which is code is presented over like this: clock and data 1110. Whenever that logic 1, the whole period, whole duration, full duration, your 1 will be logic 1 will be available. Whereas in polar RZ code, when it comes 0, then you are in the middle of the data, it's getting down. That is the difference between polar NRZ and polar RZ. So your code pattern also it's getting vary here. Manchester encoding, in Manchester code, each bit of data is signified by at least one transition. So it's ensured by at least one transition. See, in the clock is there, the same code also represented. So each significant bit it's represented by a one pulse, one transition, whether it may be from 0 to 1 or 1 to 0. So Manchester encoding is therefore considered to be a self-clocking. It's just itself acting as a clocking, okay, which means an accurate clock recovery from a data stream is possible. And compared to bandwidth of simple NRZ and NRIZ encoding, Manchester encoding is somewhat better. So this is Manchester encoding. So I hope you understand unipolar NRZ, unipolar RZ and Manchester encoding and properties of line codes. Thank you.